I went down to the Effect Miami meetup, which was a great event put on at the lab in Miami. So thank you again to the folks at the lab for hosting the meetup there. And it was organized by Riel, one of our community members. And it was a fantastic event. There were probably like 50 or 60 people there, maybe. I'm just totally guessing, but there was quite a substantial audience. And it was just like, it was a very cool event too, because it was a lot of folks who had like heard about Effect, but hadn't started using it yet, were evaluating it for their companies maybe. So it was a lot of like talking to people about um, why they were interested in Effect and like what could Effect do for them and kind of the cool parts about Effect. Yeah, so it was like a really interesting audience. Typically when we go to like Effect days or whatever, it's like already everybody who's just like Effect pilled and wants to talk nerd out about Effect. But in this case, it was more like talking to people who are like evaluating the technology. So it was a really fun event. And yeah, so I went last. So both Ariel and Dax gave really, really good talks. Ariel kind of focused on like Effect for agentic development from like a practical perspective. You can watch his talk on YouTube. And Dax also talked about Effect for how they use Effect at open code. So open code is an open source code base, obviously, so you can go take a look. But he kind of walked through the things that they have been getting the most value out of so far with Effect, as the whole team sort of like gets used to using it and is learning it and whatever. So both were really, really great talks. And then I came in and just ruined the whole thing with my clickbait presentation. You don't have to mute yourself, Mattia, because I'm pretty sure the noise isn't coming from you.
Oh,
I
no
think it's
worries.
on my end. But anyway, I figured I'd run through the slides and just sort of like talk a little bit about what I spoke about there. If there's questions, you can stop me. Mattia, you can interrupt me at any point. I kind of don't want to have to give this presentation twice, so it can be very casual. But I started off this talk by kind of polling the audience about, who in the audience was an engineer, because it was a mixed audience of like both engineering and non-engineering. But the majority of folks were engineers. And the second question I posed was, how many folks are using agentic coding tools in their daily work? And every single engineer in the room obviously raised their hand. And so the point being that, agentic coding tools have become quite ubiquitous in the past year or two, which is pretty wild if you think about uh, how quickly the whole way that we go about software engineering and software development. It's not Twitter hype, it's X hype. Listen, I'm I'm a 90s kid. I still call it Twitter. You can't change my mind. But anyway, the third question I asked the audience was, what if who in the audience has had the experience of writing some code with their agent and then having to scrap everything that they wrote because the agent just went wild and wrote total slop? And again, pretty much everybody in the audience raised their hand and had that experience. And so the point I was making is that these tools are really great, but they have problems, and we're spending a lot of effort now engineering our harnesses, trying to figure out different ways of prompting agents, using skills, all of these different tools to try to keep an agent on track, engineering the environment that the agents run in. And we spend a lot of time on this, so I think it's worthwhile to kind of like talk about different ways you can keep your agent from writing slop and why so many people are talking about Effect for that use case. So I don't really need to introduce myself here, but there I did. So this is my slide. I need to get a slide like Mattia's recursion slide for my presentations. But anyway, I moved on to this slide, which was kind of talking about why so many folks are talking about effect for agentic development, obviously I could stand up there and talk about how great effect is, all the tools it provides, and blah 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 blah. But obviously, people are going to consider me biased since I'm a core contributor to effect, and so uh, the point of this slide was to basically tell people, don't take my word for it. Look around in the community and see all the other folks who are respected in the community who are engineering like real world applications with agentic coding tools and using effect and getting a lot of mileage out of effect for that purpose. There's many people out there talking about how good effect is for agentic development. So again, you don't have to take my word for it. Go read Twitter, Mike, and you can see for yourself. And one of the tweets that I really like is actually from Matt Pocock, where he talks about how there's literally no better agentic experience. I think I can link to it. Yeah. There's literally no better agentic experience for building backend type stuff in TypeScript. Once you see it through that lens, it's addictive. And then Kit just, reacting that it's the greatest day of his life. So again, it's not just us, the effect community, the effect developers talking about how good it is. There's other people out there too discussing effect and why it's so good for this purpose. But the logical next question becomes, why? Why is effect considered so good for agentic development? What properties does effect have that make it a really good fit for agents? And what are the like tools that effect gives an agent that makes it so that makes it a great assist for the agent to write good quality software? Open code testimonial would be good on that slide too. Yeah. Well, there's Dax tweets about effect, I think. But anyway, I moved on to, so we wanted to talk about like why effect is so good for this purpose, blah blah blah. And I said to understand why effect is so good, we have to first take a step back and talk about like the coding loop, the agentic coding loop that we all go through every single day while we're working on our different projects. And usually it starts with some prompt, right? It could be a simple message that you send to the agent, or it could be like a crazy detailed specification that you've spent, half hour working with your agent, fine tuning and creating all these different subtasks and whatever. But at the end of the day, you're feeding some input into the agent to produce the code that you want. And then the agent will take that input and it will perform some generations. It'll write the code that you've specified that you want. It'll try to accomplish the tasks you've given it. And once the code's been written, most of our code bases have some checks built into them, right? Linting, formatting, et cetera, et cetera. There are some checks that are built in, and then sometimes the agent will also run the code and do smoke tests and things like that to figure out if things are working properly. But I kind of want to focus, when talking about effect and why it's so good and what tools it gives the agent, I want to really focus on both the generation and the check phase, because I think this is where we get the most bang for our buck out of effect. So if we first focus on like the generate phase of this, back and forth, there are properties of effect like for coding itself that make it really, really good for agents. It's the same properties that make effect good for coding for humans once you get over like that syntax hurdle, right? Human brain has to get over the syntax burden of effect. Agents don't care. So they can really be productive immediately with effect. And what do I mean by like the syntax? Like what is helpful about effect syntax that make it good for agents? Well, one thing is it's very structural. So pretty much every effect program is written the same way, or can be written the same way, the same structural way, right? There was a tweet from Dylan a while ago about how you use generators for writing your business logic, and then you compose higher order behavior onto that effect program in the pipeline afterward. And you could give that framework to your agent, and every single effect program could follow that exact same pattern. Every effect you build in your app could just be composed from those two rules, right? But you can take it a step further and show your agent the canonical way that you and your team like to engineer services. And what's great about that is all of the business logic related to that one thing, that one concept, gets encapsulated inside that service. So there's the property of having nice little boxes of logic that are related to a particular domain or concept. It's really great for agents because it allows the agent to stay really focused and have very tailored context when developing a particular piece of code in your app, as opposed to like more standard TypeScript code bases where agents might need a lot more context to be able to work on a particular piece of logic or behavior in your app. And also services have a defined structure to them as well that fits in really nicely with the way that agents write code. I don't know if you folks have noticed, but Sam actually talked about this a few weeks ago on Effect Office Hours, but agents really do have a tendency to like write helpers first, and then like at the very bottom of the file, they write the actual like logic that you're interested in. And that fits in kind of well with the way that you build services in Effect, because you first engineer the interface of your service, like the contract you want it to expose, and then all the business logic and stuff like that happens at the bottom of the file usually. So there is like kind of a nice mapping there, but getting back to our loop here, there are structural qualities about Effect that make it really good for the generation phase of like actual writing code. But even more than that, the loop that you go through between generating and then performing checks and feeding the output of these checks back into subsequent generations, this miniature loop inside the overall agentic coding loop is even more important, right? Giving the agents the ability to run like specific checks that are tailored towards your app and the type of code that you want to write is extremely important to keep the agent on track and like make sure it's writing the right things. You think of like the most basic things could be, like I said before, linting and formatting, type checking, and things like that. If you've got the Effect LSP installed, which you should, you can get even more semantic information out of the type checking phase, which we can show in a minute here. But when an agent is writing an Effect program, it has access to the whole world of that program right in the type signature. So it really has to do a lot less work to figure out what is that program going to produce, what could it potentially fail with, and what does it need to actually run, right? That's all encoded in the type signature. And obviously you can build on top of this, right? Within a particular code base, you can engineer even more back pressure. So pushing back from checks into the generation phase, that like back pressure engineering, the agent to regenerate code to follow patterns from your code base. And it's really easy to do with Effect because you have so much information in the type system. And again, a really great example of doing that, engineering back pressure into your agentic loops, is the language service plugin. So like these are two simple examples of the Effect LSP at work. I like this example on the left of like the floating effect problem. It's the same concept as like the floating promise problem. Not exactly the same because a floating promise is actually running, but a floating effect is not. But the idea is the same, where if you're never like yielding or using this effect at all, it's floating, it's never going to run. And this would type check if you don't run the Effect LSP as part of type checking. Like this would actually be a program that fully type checks but has like semantic errors in it, right? You'll never see this log in your program. But by engineering that additional back pressure in with the Effect LSP at compile time, you can feed this diagnostic, which we're seeing, during development, into the agent at compile time. So the agent can actually get access to that information and fix this. And the messages that you get out of the LSP are in plain English. They're in a language that the agent understands. And so it's much easier for the agent to take this and use this feedback to fix this problem, right? It's very targeted. Similarly, this program on the right actually wouldn't compile. This would fail type checking. But if we don't have the effect LSP installed, all the agent gets is type user repo is not assignable to never. That's not really like useful for a coding agent. It's very difficult for, like, we might know what that means as people who are like working on effect programs and like have that context in our head, but an agent is going to have no idea. Like, it's going to have to do a lot more work to figure this out. But with the effect LSP installed, again, a tool that's putting additional back pressure into the agent to regenerate code based on feedback, it gets a plain English description of the problem. The effect requires a service that's missing from the context, the user repository, and it can use that information to fix this problem, right? So the main concept I'm trying to get across here is that you can use effect programs. Like, effect has a lot of properties that make it really easy to not only like do the code generation phase, but also to engineer additional back pressure and checks into your program. Go ahead, Mattia.
One thing that is basically the takeaway, I would say that that's not something you can do because that's a tool like the LSP, but it's something you can do because the properties of effect have that very strong semantic encoding embedded in the type system and /or in the code, and that's something that's the real property that no other framework or no other like library has. No other library has that strong semantic encoded in type system. That's the thing that leverages the possibility to do those back pressure tools. Without that, you cannot do that.
And there's even more tools built into the LSP that the agent can use to get information out of an effect program because of how much information is encoded in the type system, because effects are lazy and can be like inspected before they're actually run, right? There's a lot more information you can get access to in an effect program than in a plain TypeScript program. So there's quite a bit to discuss here about like why effect has all these great properties that make it good for coding agents. And we could talk a lot more about this if you folks have questions. But the logical like next question you might have is, if we looked at this agentic loop, you'll notice I'm missing a piece over here, right? And I think right now, we as developers who are using these coding agents in our daily lives are extremely focused on the local development loop. And I don't just mean like local development as in like the agents running locally. Obviously, you might have agents running in sandboxes and whatever, but the point is we're focused on the actual development of software with our coding agents. And I think that's fine. That's where we're starting, but I don't think that's where we're going. And I think there is a massive gap right now here, which is when the software is actually running, right? When your application is actually running in production. Right now, there are very few tools out there. So there's much less interesting discussion and tooling going on in this space where your application is actually running, but we're not using that feedback in any way, shape, or form to further improve the code that's making up our application. And I think effect has a real opportunity to shine here as well. So where I think we're going is kind of beyond just code generation, where the feedback loop is expanding into more of the software development lifecycle, and the agentic information that you get out, the information that the agent provides to you becomes useful not just for the software developer, not just for the software developers on the team, but also for other folks involved in the software development lifecycle, like, your C-suite or your product engineers or your salespeople, whatever. There's a lot more information that the agent can make use of from a running application, in my opinion, than from the app at rest. And so we're kind of like here right now, right? Our loops are primarily running on code. I think we're getting more into this space with like, code review agents that are running on PRs and things like that, agents running in CI to do things. But I think where we're going is kind of here, where there will be the concept of like an always on agent that actually uses information coming from your running application to figure out things that can be improved. And so instead of the agent being like just a code editor, I think it'll become much more of like an operator in the future. And so, like, the logical conclusion to this is that instead of the prompt being something we feed into the agent to get it to do something, the application is going to become the prompt. The application is going to be the thing that feeds agents with context needed to continuously improve the application, the system, et cetera, et cetera. And I like to use the term software factory for this type of like application feeding context into the agent to continuously improve the application, right? That whole kind of like a larger scope agentic development loop. And it all starts with like signals that your application exposes. And again, I think this is a huge opportunity for effect to be very beneficial for folks because you get all of these things built in, right? You have logging built in, you have metrics built in, you have traces built in, you have errors built in. And so you already have a wealth of information you can expose from your application to your running agents. But even beyond that, if you like keep going, right? And you keep thinking about, okay, like what information do humans use to improve applications? Well, we use user feedback through the form of like ticket systems or feedback systems, whatever. We look at traffic patterns in our application. We look at benchmarks. We look at all sorts of different things about our running apps to improve them. And I think these signals about our application are things that we could feed into this like hypothetical software factory. And inside this software factory, these kind of always on agents are synthesizing all of this information together. They're kind of like deciding what to do with it and figuring out ways that they can, excuse me, improve the application. They can fix issues for you automatically and open PRs on your behalf. They can verify information that's coming out of your application. They can detect anomalies before you even notice them. They can figure out opportunities for improvement based on these signals that are coming in. And this is all really interesting. And I think like the software factory, again, my hypothesis is that this is going to be like the future. I think this is like we're already seeing companies moving in this direction where agents are getting access to more like runtime information to do things. But I want to be really clear. I don't really think that this negates the need for humans to be in the loop. I actually think in the future where software factory is kind of the new agentic loop, I think humans are even more important in that scenario than we are in the coding loop. Because we need to look at this information and figure out, okay, like the agent's giving me all of this, like these things. There's fixes coming in. There's new features that the agent's proposing based on application feedback. There's new features I want to implement in the app that the agent hasn't brought up. And so I think it's actually going to be even more critical for humans to be in the loop and in control of the software factory. And so I think my hypothesis is like there will be some automated actions that humans allow basically humans will have the ability to determine which of these things agents can act on autonomously, which things we want to remain in control of, and then also like give our own feedback into the software factory, like, hey, you haven't mentioned that feature X is something that I want in the app, so why don't we go ahead and figure out how to build that.
I really
Go ahead,
I
Mattia.
really I really like the terms that you put on the bottom, like prioritize, review, and approve as the main focus for the humans, because that is something that focus on what we how at least I have like been perceiving recently, that thanks to the new LLMs that we have, the new tools that we have, we are all basically moving away from being just pure coders, and we are slowly more and more becoming like code reviewer and product manager deciding what's the next, and also approving what goes in production and what is not. And I really like also how that projects to the software factory idea, because if we have a software factory, then we become something like a production supervisor. We are not the one that are actually producing software. We are the one supervising how it's being produced. So we are basically supervising the flows. We are supervising how things are going, and we just put our hints where things are going bad or are not going in the direction we actually want the entire production to go to. Even though I don't like the terms software factory, it's true, it's how it's called, but I don't like that because it gives the idea that it's too fast, it's producing a lot, and we connect usually something a lot to something not good. But that's
I
behind
mean,
the scene what it really is, because it's automated for the most part, so we should speak about the factory.
the other thing that I want to point out here is that the human in the loop is not just the engineer in this scenario. Because the software like factory concept is exposing a lot of information, the human in the loop could also be non-technical individuals, right? It could be people like, like you said before, your sales associates, your C-suite, your whatever, like people who want to get insight into parts of the application that are under development, for example, right? There's a lot that can go into this bucket. It's not just like information's going in and fixes are coming out. There's a lot of other pieces of this software factory that could be beneficial to other members of the team, right? Like you could imagine the agents feeding all of this information in, and your sales team is seeing like, it suggests to your sales team, for example, that traffic is like really high at for particular I don't know, like there are different things that could go in here that are not just engineering focused. Software factory also feels like a buzzword from day zero, like vibe coding. It is a buzzword.
Yeah.
You're welcome. I see Max decided to spoil our product roadmap. You're welcome. So yeah, I think that it's no secret that like this is where companies are moving. I think that like uh the there are a lot of folks moving in this direction already. Think of like there was a big announcement from like Linear a few months ago about moving their tooling in this direction. There's a bunch of other companies like Sentry has some tooling going in this direction, right? So like, I don't think it's any secret that this is the logical progression of things. But I think it's very, very early. And I think there's a lot of opportunity to like do this correctly, do it well, do it right, and give people the primitives to do this nicely. And that was the end of my talk. My slides are here on my GitHub. And yeah, so if you have questions, let me know. But otherwise, we can talk about like effect code now.